So the point of all of this is to learn how we can count atoms by weighing them. And to do that, we need one more conversion factor besides 1 mole equals Avogadro's number of things. When we're counting nails by weighing, what we need is the weight of a dozen nails. Then we can use the weight to figure out how many nails we have. For atoms, we need the mass of 1 mole, 1 chemist's dozen of atoms. So the molar mass is the mass of 1 mole of atoms of an element. So molar mass is the mass of a mole. It's numerically equal to the atomic mass. Atomic mass is the mass of an atom. What unit do we use to measure the mass of a single atom? AMU, atomic mass units. So that number is on the periodic table, right? If we want to know the mass of an average carbon atom, we look at the periodic table. Below carbon, it says 12.01. 1 carbon atom weighs 12.01 atomic mass units. The molar mass, the mass of a mole, 6.022 times 10 to the 23rd carbon atoms, is the same number, just use the unit grams. 1 mole of carbon atoms weigh 12.01 grams. It's not a coincidence that those numbers are exactly the same. They set up the definitions of mole and atomic mass units in such a way that that would happen, because it makes things really convenient. So Avogadro's number is the number of carbon-12 atoms. That's the particular isotope of carbon that has 6 neutrons and 6 protons, is exactly 12 grams of carbon-12. So an atomic mass unit is 1/12 the mass of a carbon-12 atom. Do you need to remember that? No. What you need to know is this, that the mass of 1 mole of atoms of an element is the same number as the atomic mass, but in grams instead of atomic mass units. Any questions? Just like the weight of a dozen nails changes depending on what size nails you're using, so the mass of a mole of atoms is different depending on what size of atom. So here's a dozen large nails, a dozen small nails. Which one's going to weigh more? A dozen large nails. Okay, there's something wrong with these pictures. Anybody tell what's wrong with them? It kind of looks like it might be the same nails, which is zoomed out on the one. Count the nails. There's not 12 nails there. There's only 11. It's like, really? Really, publisher? The point of the picture is that it's a dozen nails. And this has happened in more than one edition of the textbook. So there's the other nail. 12 nails. Okay. Draw it in. Here we have a watch glass with a mole of sulfur atoms. And here's a watch glass containing 1 mole of carbon atoms. Now we can't look at that and see, did they get it exactly right? Because atoms are too small to count. A mole of sulfur, that's 6.022 times 10 to the 23rd sulfur atoms. And a mole of carbon, 6.022 times 10 to the 23rd carbon atoms. A mole of sulfur weighs 32.07 grams. A mole of carbon weighs 12.01 grams. Because just like with the nails, the smaller nail weighs less, and so a dozen of the small nails weighs less than a dozen of the large nails. Sulfur atoms are larger and weigh more than carbon atoms. Mole is a counting number. It's a particular number just like a dozen. Any questions? Mole is just this weird, for a lot of students, mole is a weird number, and we throw it around. We're going to be tossing it around for the rest of our session, and they're like, what the heck is that? It's like a dozen. We all understand a dozen is just 12 things. A mole is this weird number of things. That's all it is. So a mole of sulfur is 32.07 grams, Avogadro's number of atoms. A mole of carbon, 12.01 grams, Avogadro's number. Lithium, 1 mole of lithium, 6.94 grams of lithium. You find lithium on the periodic table, and underneath lithium, it says 6.94. The lighter the atom, the less mass in 1 mole of that atom. Okay? So molar mass is our conversion factor between grams and moles. Molar mass is a really, really important idea in chemistry. Because when we look at chemical reactions, those happen between particles. And so we have to think about numbers of particles, but they're too small to weigh or count. They're too small to count. And so we weigh large numbers of them, and we use the mole as a unit that's convenient. Because if you're talking about eggs or donuts, you go to Costco and you can buy 5 dozen eggs. That's easier to deal with than buying 60 eggs. 5 dozen is 60, but 5 dozen is a more useful number. And so with atoms, we use the mole because it brings it down into more useful numbers. Okay, we can say, oh, well, that's 2 moles, instead of saying, oh, well, that's, 1.2044 times 10 to the 24th atoms. Okay, any questions? Yes?
So like 5 dozen could easily, say that's 60.
Mm-hmm.
But in moles, they're so small. Is it exact when you convert it?
That's a good question.
Or is there a tolerance?
So moles, 1 mole is this ginormous number of atoms. Is it exact? No, it's not exact. We do know Avogadro's number to more than 4 sig figs. It goes on beyond 6.022. But for most of the calculations that we do, 4 significant figures is plenty. And so we just use the 4 sig figs. But it's not exact. There's no way we could have it be exact, and we don't actually need it to be exact. It is defined as the number of carbon atoms in exactly 12 grams of carbon-12. So is there a particular number? There is, but we can't really figure out exactly what it is, and there's not really any point in doing so. It's a good question. Any other questions? So let's use this. Calculate the number of moles of calcium in 91.4 grams of calcium. So these calculations almost always end up being dimensional analysis. So here's the number. So we write that down, 91.4 grams. And then it says calculate the number of moles. So this is the unit that we're looking for. So we're starting with grams, we're ending with moles. The abbreviation for mole is MOL. It is not lowercase m. Lowercase m is meters. This spring semester, a bunch of my students, I don't know what happens. One person gets a crazy idea, and then it spreads to everybody else in the lab section. It's the weirdest thing. M is meter, MOL is mole, okay? And it needs to be lowercase. So grams to moles, we can do that in one step. The conversion factor is the molar mass. And all you need to find the molar mass is the periodic table. So let's look up calcium. 1 mole of calcium atoms is how many grams? 40 point, I can't remember, 0 what? 0.78, so 40.08, that sounds right. So a chemist's dozen of calcium atoms weighs 40.08 grams. That's our conversion factor to convert between grams and moles. So then we put this down, we got 91.4 grams. We have 1 arrow in our path, so we have 1 conversion factor. The units, gram to mole, and here gram, so we write mole here. And then I want the gram to go away, so I'm going to divide by grams. The grams cancel out, and then I need numbers. So I go up here. 1 mole of calcium is 40.08 grams. 1 mole of calcium, 40.08 grams. Then you need your calculator. That's 91.4 times the top, divide by the bottom. So times 1 divided by 40.08. And I look at that and I see that my starting number had 3 sig figs and the molar mass had 4. So this is going to be 3 significant figures, 2.28. And I'm going to write down 2 extras. And the unit is mole. And then when I round that, 2.28 moles. Any questions? Let's do another one. This one's backwards. Calculate the number of grams of sulfur in 2.78 moles of sulfur. So, dimensional analysis. Pull out the number with its unit, 2.78 moles of sulfur. And the unit I'm trying to find says calculate the number of grams. So I need grams of sulfur, and between moles and grams is always just 1 step. My conversion factor comes from the periodic table. 1 mole of sulfur weighs 32.07 grams. That's just the number under sulfur on the periodic table, the average atomic mass. Oops. So I start with my given number, 2.78 moles. I have 1 arrow, so that means I have 1 fraction. Moles to grams this time. Moles to grams. If you're having trouble with these calculations, make sure that you're writing down the path. That is the key. Some students can have the path in their head and do it just fine. Awesome. If you can't do that, write it down. Okay? It's fine. Just write it down. So then I put mole down here, and the moles cancel out. The units are telling me what to do. Now I've got my relationship here. 1 mole for sulfur is 32.07 grams. 1 mole is on the bottom. 32.07 grams is in the numerator. You don't have to remember, should I multiply, should I divide? The units are going to tell you what to do. 2.78 times the top, divide by the bottom, times 32.07 divided by 1 equals. And again, I see that I'm going to have 3 significant figures. So there's my 3 significant figures, and I'd like to write down 2 more, just in case. And then I'll round, and when I'm rounding, I look at the next digit, and I see that's 5 or larger. I have to round up. So this is 89.2 grams. Any questions? So I know some of you have a hard time with sig figs. It'll probably be hard to get an A if you don't get sig figs, but you can definitely pass the class. So here's a shortcut on that. Many times, however many sig figs you started with is how many you end up with. If that even is too hard, 3 or 4 sig figs is usually pretty good. That's usually what things end up being. Any questions? Seriously? Okay, so now let's take it 1 step further. How many carbon atoms are in a 0.58 gram diamond? Well, what is diamond? It's a form of carbon, right? So a 0.58 gram diamond means 0.58 grams of carbon. I wouldn't do that one to you on a test. So this is carbon. Okay, so let's write down the numbers that were given. There's only one. So 0.58 grams of carbon. And what are they asking us to find? Atoms of carbon. Well, how do we do that? How many atoms per gram of carbon, or how many grams does an atom of carbon weigh? Do we know that number?
Yeah, 12.01.
Well, we've got the 12.01 grams. How many carbon atoms is that?
6.4.
It's Avogadro's number. Yeah, so there's two ways to do this problem. You can do it in one step or you can do it in two steps. So we know from the periodic table that 1 mole of carbon is equal to 12.01 grams of carbon. How many atoms in 1 mole? Well, it's Avogadro's number, 6.022 times 10 to the 23rd atoms. So we could go grams to moles to number of atoms, or we could go grams straight to number of atoms, because 12 grams of carbon is 6.022 times 10 to the 23rd atoms, because that's what a mole means. This is like with eggs or something. If a dozen eggs weighs 2 pounds, well, a dozen is 12. So you could also say 12 eggs weighs 2 pounds, right? And that would be a conversion factor that would save you a step. Let's do this one in one step. So 0.58 grams of carbon. Doing it in one step, we're going to go straight to atoms. And then I put grams on the bottom because I want the units to cancel out. 12.01 grams of carbon is equal to Avogadro's number of atoms. So 12.01 grams down there, and 6.022 times 10 to the 23rd atoms on the top. So then we get out the calculator. And you need to be able to use the EE or EXP button on your calculator correctly. So you should pull your calculator out, do the calculations. If you're not coming up with the same answer that the rest of us are getting, then talk to me in lab and I'll have a word with your calculator. Okay? It's your calculator's fault, isn't it? Yeah. So we'll straighten out your calculator in lab today. It's really, really important. So 0.58, I'm going to times the top, times, and this is how you enter it, 6.022, and then press the EE or the EXP button. Do not enter times 10. EE stands for times 10 to the. So I've got EE and then the exponent 23. And then I'm going to divide by what's in the bottom, 12.01 equals. So this is what my calculator is showing me. So this is calculator language. If you write that on your paper, I know what it means, but you need to translate into human math language, okay? Some calculators will show it to you differently. Some have a little times 10. You know, they're all a little bit different. This is what mine's showing me. That E means times 10 to the, okay? You cannot just skip that and just say, well, I don't know about that. I'm just going to not write that part down. That's really, really important. So again, I should always check sig figs. So here I've got 2 sig figs, and so this time it's going to be here. And so I look at the next digit, and it's less than 1, so it's just 2.9 times 10 to the 22 atoms. Any questions?
What if,
Hmm?
what if you were to, like, as far as calculating it, what if you reach the 0.58 times the top of it, which is the letter number, and then you equal it, and then you divide it, that's totally different?
No, that is the same. So if you do 0.58 times 6.022 EE23 and press equals, and then divide, that's fine. It'll get the same number. The thing about your calculator is, it's very good at doing exactly what you tell it to do, but it doesn't know what you're trying to find. It just does what it's told. And so when you have subtraction in the numerator or multiplication in the denominator, you need to be careful that you're communicating what you want to your calculator. So it's important. Any other questions? Yeah.
Is that 12.01 the grams for the atomic mass?
Yes. Yep. And we just got that from the periodic table. You don't memorize those unless you do them over and over and over again. I've got a bunch of them memorized just from using it. But you'll always have a periodic table. Any questions? Okay, this is one going the other way. So calculate the mass of 1.23 times 10 to the 24th helium atoms. So again, the strategy, read through the problem, write down the number. 1.23 times 10 to the 24 helium atoms. So atoms of helium. And what do they want to find? Mass. What's the unit of mass? Grams. So we want grams. So we're going to need some information from the periodic table. So helium is 4.003. I remember the 4, but not the rest of it. So on the periodic table, we see 4.003 under helium. That's the atomic mass. So one atom weighs 4.003 atomic mass units. 1 mole weighs 4.003 grams. So we can do this in one step, going directly from atoms to grams, like we did in the previous problem, or we can do it in 2 steps by going through moles first. I'm going to do this one in 2 steps just to illustrate what that would look like. So this number from the periodic table, that means that 1 mole of helium is equal to 4.003 grams. 1 mole equals 6.022 times 10 to the 23rd atoms. This side, that's always true. 1 mole, 6.022 times 10 to the 23rd things. That's what 1 mole means. The mass over here will be different depending on what element you're looking at. So that's specific to this problem. So if we're going to do 2 steps, atoms to moles to grams, I'm going to start out here 1.23 times 10 to the 24 atoms. I'm doing 2 steps, so I'm going to have 2 fractions. Atoms to moles to grams, atoms to moles to grams, just like the path, atoms to moles to grams. And then I need to put units in the denominator to cancel out the ones I need to get rid of. So I need to put atoms in the denominator. Because atoms divided by atoms is equal to 1, and that doesn't change anything. And then I need to divide by moles over here to cancel those out. Then I put numbers in. So the relationship between atoms and moles is always the same. 1 mole is Avogadro's number of things. 6.022 times 10 to the 23rd. The molar mass will be different for different elements and compounds, but 1 mole of helium weighs 4.003 grams. Any questions? So now we use the calculator. You put in the number you're starting with, you multiply by what's on the top, you divide by what's on the bottom. Multiply by the top, divide by the bottom. Continue on until you get to the end and press equals. There is no need to write down intermediate values. I know some of you like to take all the tops and multiply them and write that down. Take all the bottoms, multiply it, and write that down, and then punch the numbers back in and divide. You can get the correct answer that way. It's more work, and you have more opportunities to make a mistake. I think we've all written down a number and transposed a couple of digits, left one out, something like that. Then you punch it back into your calculator, and you've got more opportunities for mistakes. It's faster and more correct to just go all the way through. So 1.23 EE24 times 1 divided by 6.022 EE23 times 4.003 divided by 1 equals. And this should have 3 significant figures based on this number over here. This is not exact, but it's got 4, and that has 4. So 8.17, there's my 3rd significant figure. Write down 2 extras, and the unit there is gram. And then we'll round that 8.18 grams, because 6 is 5 or larger, so we have to round up. Did your calculator show you that number? If it's showing you a really, really big number, that's because you inadvertently multiplied by 10 to the 23rd instead of dividing. So that puts you off by a factor of 10 to the 46, which is like astronomical. If you're having problems with that, please see me in lab and we'll figure it out together. Any questions? So just to get an idea of how big Avogadro's number is. So 22 pennies contain 6.022 times 10 to the 23rd copper atoms. If we had that many pennies, 6.022 times 10 to the 23rd pennies, that would cover the Earth's entire surface to a depth of 300 meters. A meter is about a yard. That's 3 football fields. 3 football fields deep. The entire surface of the planet in pennies is Avogadro's number. Is that a big number? Yeah. 1 crystal of granulated sugar has a mass of less than a milligram, a diameter of less than 0.1 millimeters. If you had a mole of sugar crystals, it would cover the state of Texas to a depth of several feet. Texas is a big state. Avogadro's number, you can't even comprehend how large it is.